RGB LEDs can help take projects to the next level, and today I'm going to show you how you can incorporate RGB LEDs into your Arduino projects, from soldering to programming. Let's dive in. Let's first take a look at how RGB LEDs work. RGB LEDs are made up of red, green, and blue LEDs which are combined to create various colors. So when an RGB LED is white, it's using all three LEDs at the same time. Our goal is to control these individual LEDs with an Arduino to create our desired colors. Now that we've got those LED basics out of the way, we can move on to connecting the LED to the Arduino. And for this, you can use any LED. For example, this is an LED from an Arduino kit, which is breadboard ready with the headers. And this is an LED from an RC car, which I've added wires to. And this is a leftover LED strip, which I'm going to be using for this example because LED strips are common and pretty cheap. I'll only use one section though, so I'm going to cut off the rest. I'm also going to remove this protective layer it has because it's going to get in the way of the soldering. Okay, I removed that protective layer so we can move on to soldering. I have some wires pre-cut and my solder ready, and I'll bring out my little clamp setup to help me with the soldering. You can use any side here, they should both work fine. I'll line up the LED in the clamps and clamp in the corresponding wire. Alright, the soldering is pretty easy. Just hold the soldering iron, touching the wire to get everything to warm up. Once everything's warm and in position, you can apply the solder. Let it cool, and you're done. Repeat the process for the next wires. Alright, our wires are soldered. Now, as a quick note, this is a common anode LED, which means that the common wire is positive. There are some LEDs, such as this one, which are common cathode, which means that they share the negative wire. The wiring is very similar, except that instead of connecting this common wire to the positive 5 volts, you'll connect it to the ground. Here's my breadboard setup. The white wire is connected to the Arduino's 5-volt power, and each one of the colored wires goes to a PWM pin. These are then connected to 220 ohm resistors, which are where the LEDs are plugged into. If you're having a hard time plugging the bare wires into the breadboard, you can apply a little bit of solder to them to make sure they retain their shape. Alright, our LED strip is connected to the Arduino, and we can move on to the programming. Alright, I've opened up the Arduino IDE on my laptop, and I've plugged in the Arduino. Here's my sample code. It assigns an RGB value to each LED in order to power them. In this case, it's RGB 255, 255, 255, which is white. Now, if you're unfamiliar with this color format, you can use a tool such as this one to help find which color you need. For example, if I wanted to create red, I could drag this slider and find that red is indeed RGB 25500. So let's upload the code. And sure enough, the LED turns on white. Now, how does this code work? Well, first I define what pin each RGB LED is connected to. Then I create a variable to store the value of each LED color. Then under the setup section, I initialize each LED pin as an output. Then in the void loop section, I assign a value to each LED based on the RGB color values. Then I invert it because this is a common anode LED. And lastly, I use an analog write tool to power each LED based on its assigned value. And this works for any color. You can change up these values to create whatever color you want. I've also created another program for that classic RGB color fading. It uses a series of equations in order to calculate a new value for each LED as the loop goes on. These equations are shown here. There are 3 sine waves, one for each RGB LED, and they change in brightness continually, but they're layered in such a way that the overall brightness level remains constant. The rest of the changes to the equation are simply to accommodate for those equations. I included a variable for pi, one to control the speed of the gradient, and another to manage at what point on the equations we're on. The setup part is the same, and this section under the void loop just makes sure that the x value stays under 1,000, so we don't have to manage any extraordinarily large variables. Then this section simply increases the value of x by the value of s, the speed, each time the loop takes place. And that's it. The equations use the value of x to calculate the brightness value for each LED, which is then inverted. Again, delete this if you're using a common cathode LED, and then send to the LEDs to power them. I'll upload it to my Arduino. Now, for some reason, my camera's having a hard time capturing the color fade, but I've also created this same circuit in a simulation in Tinkercad, and as you can see, it uses the same equations and is doing the color fade I showed earlier. Now, if you want to speed up the color fade, you can increase this S value, and it will increase the speed of the fade. And that's it. Now you have all you need to know to implement RGB LEDs into your Arduino projects. Thanks for watching.